Now we're going to get into the heart of the conics. Again, addressing Common Core standards relating to conics, but also relating to algebraic rational expressions. So when we get into this, you will see that all of the conics are related, not just in terms of where they come from, the cutting of cones, but also how their formulas are built. In fact, they all emanate out of one general formula. Ax squared plus by squared plus cx plus dy plus e equals 0. That is the general form for conic equations. That is the general form. Everything else is just going to be some version of that, some adaptation of that. So, if we start taking a look at the various formulas, let's deal first with the easy one. Let's deal with a circle. A circle is a lot of times given as x squared plus y squared equals r squared. Now, I don't really love that formula. I much prefer, even though many books give this formula, I much prefer x squared plus y squared equals 1 with the r squared in the denominator. Couple reasons for that. When we go to an ellipse, we have x squared plus y squared equals 1, but it's over a squared and b squared. The only difference between a circle and an ellipse are the fact that the radii are the same on a circle, but on an ellipse you have a major axis and a minor axis. One is going to be larger than the other. So we need to deal with that. Now, for a hyperbola, our generic would be x squared minus y squared equals 1, all over a squared and b squared again. Now, sometimes books get real bent out of shape about which one is first, a or b. Is b or a, and which way does it go? I don't get bent out of shape about that. We'll talk about that in a little bit. Finally, the one that's really different is actually a parabola. And that's going to be x squared equals 4py. Okay, 4py, or y squared equals 4px. This one is the one that's the weirdo. You'll notice the reason to address all of these three at the same time is because in essence they are the same formula. There's just a minor variation whether the bottoms are different or whether it's a plus or whether it's a minus. Those are the things that make them different. Now, at this point, all of these equations, all four of them at this point, their key point is 0, 0. We don't always want a key point at 0, 0, so we need to adjust it. Well, just like we adjust horizontally or vertically using a minus or a plus in with the x when we're talking about the previous graphs we've dealt with, we're going to do exactly the same thing with our conics. For the circle equation that you will be expected to know is x minus h, the quantity squared, over r squared, plus y minus k, the quantity squared, over r squared equals 1. The only difference between our previous equation and this equation is the fact that now, instead of just x squared and y squared, we have x minus h, y minus k. Their center and our key point here is now going to be at h, k. The reason we don't use x and y, they're already used. This is the x point. This is the y point. Now, for an ellipse, You have x minus h, the quantity squared, plus y minus k, the quantity squared, equals 1 all over a squared and b squared. The key thing to remember for ellipses is bigger is major. For a hyperbola, you have x minus h, the quantity squared, minus y minus k, the quantity squared, equals 1, all over a squared and b squared again. In hyperbola, first is important. So we'll talk about that. Finally, if we want to come down to the parabola, we have x minus h, the quantity squared, equals 4p times y minus k, or the corresponding formula, y minus k, the quantity squared, equals 4p x minus h. So, we have all of those key components. Now, by the way, also books differ. P, is it positive, is it negative? We'll deal with all of that coming up. But in the end, this is what we're talking about. So, you have standard equations that you must know and be able to give on a quiz. So if I said give the 4 conic formulas, these are it.